The next thing in the book on energy sector is microgrids. It is a bit of a whiplash in terms of understanding the arrangement, but just keep all the library of podcasts in energy, and you can always go back and forth and choose the ones you want and or arrange them the way you want in terms of learning. Okay. Microgrids, it's a concept that is now gaining more and more usage, and it is implemented more and more as well. Even before it was called microgrid, basically people were generating energy locally, even in the late 1800s in terms of windmills and solar panels. Yes, way back when, before we started worrying about global warming. Ranking and results by 2050, number 78. So it's an enabling technology. Cost and savings are embedded in renewable energy. So this is about distributed versus local generation of energy. I'm taking some material directly from Bending the Curve. This is in chapter 11 of that course that you can find on my YouTube channel if you wanted to brush up on the whole chapter. It's about emerging technologies in energy, which includes a couple of figures that I'll show in terms of integrating different sectors, especially transportation, into the energy grid. So the idea of microgrid works with the smart grid technology, which is not explicitly mentioned yet here. So this is basically new ways of operating the grids that will be needed. Deployment of the distributed generation and associated distributed energy sources, such as energy storage, requires visibility to and control over this new paradigm, smart grid. Smart grid is a grid with intelligence to maintain and increase the efficiency and reliability of the grid. So it has built-in technologies based on AI, machine learning, and data analytics and so on to respond to supply and demand. Provide grid operator with visibility and remote control of the system components through sensing throughout the transmission and distribution network. So the smart meters, smart grid, microgrids, nanogrids are all integrated to give the operator a control to monitor the situations at local scales and then respond appropriately in terms of dispatchability, power allocation, etc. Provide two-way communication and controls to enable a path for grid automation and electricity markets participation. Okay, the figures from that book, Bending the Curve, goes through this building of this in several steps, but I jumped and included this already set up here. Basically has fuel cell and hybrid power generation. This is gas turbines, for example. Renewables with electrolysis, hydrogen storage. So you have hydrogen as part of the local grid with consumers, and utility is still included in there. So you can see there are hybrid vehicles, internal combustion engines, hydrogen vehicles, there are industries, there are commercial buildings, there are residences involved, and so on. So it's not going to be just microgrid, but it's going to be a combination of distributed and utility scale productions, as well as different biogas combinations and different users that are on the grid, but the grid itself is also distributed with microgrids at scale. So this is from this book. Drawdown is the solar settlement in Freiburg, Germany. 59 home community is the first in the world to have a positive energy balance. This is happening more and more now, with each home producing $5,600 per year in solar energy. You can see how beautiful it looks and how useful it is. That's solar energy profits, sorry, $5,600 per year in solar energy profits. This is where the conflicts with the utility companies come in. The way it's supposed to work is that you use the energy from the utility company when you need it, but when you produce excess, you're able to put it back on the grid and get reimbursed for it. But will the utility companies keep playing this game if it begins to cut into their profits? This is a key question. The way to positive energy is designing homes that are extraordinarily energy efficient, what designer Rolf Disch calls plus energy. Okay, so the utility companies themselves have to be incentivized to play this game. Coming to microgrid technology, a microgrid is a collection of generation resources, loads, and other distributed energy resources that are that presents itself to the grid as a single controllable entity, instrumented IoT, Internet of Things, etc., to be able to be treated as one entity in order to provide ancillary services to the grid in support of grid operations and separate from the grid in the event of a grid outage and operate in an islanded mode. So if you have a natural disaster like a cyclone, typhoon, hurricane, floods, earthquakes, etc., and if you get disconnected from the main grid, you're able to work independently with the local distributed energy generation and so on. So this is the distributed and central generation. Tiger, I forgot what it is, but I'll add it in the next podcast. There is our microgrid serving several commercial buildings connected to the main grid, as well as supplying here separately. There are residential users on the grid with their own solar, their own charging stations, their own biogas, and they are connected indirectly through the Tiger stations here. So it's the figure we saw before with the slight modification. As I said in that book, we build it step by step. So in principle, an islanded microgrid can provide electricity to grocery stores, fire stations, gasoline stations, and hospitals in the adjacent community and can assist the utility in restarting the grid. The potential of microgrids is driving the evolution of microgrid controllers to communicate with loads, generation resources, and other DERs, distributed energy resources, for example, energy storage systems, and thereby optimize the grid connected microgrid performance, provide ancillary services, support engagement in the electricity markets. This is the idea of putting energy back and determining the prices. Manage seamless islanding and reconnection, so back and out of the grid and back on the grid. Provide emergency services to communities adjacent to the microgrid. So in addition to the microgrid controller must communicate in the future with the utility and other microgrids to provide or buy integrated system operations or by services outlined. Okay, so Nano Grid is another concept that we will not get into, but that is at a very local scale, like this commercial building, which could be offices, hospital, I don't know, whatever else you can think of, has its own grid with its own generation within it, and you can see that it's connected to microgrid, so maybe it can also disconnect from the microgrid and operate on its own when needed. So controllable grid within a microgrid and can disconnect from the microgrid when it goes down and provide ancillary services to the microgrid. So it can keep running the emergency systems, like if it's a hospital, all the ventilators, refrigeration, air conditioning, lights for operation, surgeries, etc., and so on. Okay. This is the hydrogen microgrid. I'm not going to say much about it. Basically, this book argues that having hydrogen storage and pipeline feeding into the microgrid can actually serve as a storage system, because it's an on and off system. You can turn it on when you want and turn it off when you don't want, unlike wind and solar, which are obviously intermittent sources. So hydrogen microgrid can be integrated into the microgrid. So as the population of microgrids increases and technology technology evolves, other possibilities emerge, including the following. Microgrids could become part of the hydrogen economy, not only utilizing hydrogen for generation and fueling fuel cell electric vehicles, but also generating hydrogen for use within the microgrid and potential export from the microgrid. Microgrids could operate at a frequency different from the grid. Okay, the frequency of voltage, etc., doesn't have to be the same. Connecting to the grid through a power electronics connection, thereby eliminating the need to synchronize with the grid. Doesn't have to constantly struggle to synchronize. It can disconnect, operate on its own, or have an electronic connection that does the connection. So, coming back to drawdown impact, we model growth of microgrids in areas that currently do not have access to electricity, using renewable energy alternatives such as in-stream hydro. So within the river, there's a small turbine that is run instead of building a huge dam with its associated problems. Micro wind, rooftop solar, and biomass energy paired with distributed energy storage. Okay, it's assumed that these systems replace what would otherwise be the extension of a dirty grid or the continued use of off-grid oil or diesel generators. Emissions impacts are accounted for in the individual solutions themselves, preventing double counting. For higher income countries, the benefits of microgrid systems fall under grid flexibility. So they don't have power outage issues, dispatchability issues, intermittency issues, but these give them great grid flexibility. But we know that even rich countries, when hit by hurricanes or tornadoes, etc., can have serious issues, as we saw in the US recently. So every country could use this, but remembering the co-benefit of reducing emissions, it's essentially a no-brainer, right? So let's leave it here and go on to geothermal energy source in the next podcast.